Okay, so I'm going to explain both the concept as well as we're looking at the code, how that will work, okay? So this is what we, hold on, let me click this button. Okay, so you can see my slide, right? Okay, so
Yes.
this is what essentially what we're doing in homework assignment number 2, part 2. It's not exactly the same, but it's very similar. So we have an object, which is a fly object. So we're assuming we have a class called flight, which is a derived class from transaction. And for homework 2, what we did is that we created this fly object, and then the same piece of code is the same process that send executable that we define. We create an object called fly f1. And then we say f1 dot get distance, and which this one, the linker and compiler, will link to the entry to the member function for flight for get distance, and then this call will be served in this manner. So this is homework 2. Okay, we're doing this. So for homework 3, we're actually looking at this picture. So we actually split the real object in a separate location or separate process. Okay, so now you see I have 2 programs. So one program is this side, the server side, this is a client side. So still I want to call it as if that it was like the previous slide. I just need to call f1.getDistance, and then I will be able to get to that. So of course that we need to figure out, well, how do I actually transfer that call into the real location of the real object, which is the fly object, and then get the result back. So here is the conceptual representation of the code for both the server side and the client side. So essentially, in the server side, you actually still need to create this fly f1 object exactly like what you did for homework assignment number 2. So this is an example of the code looks like. You're going to have this next slide. So this is the place, that the first few lines, I create the fly f1. Okay, you see that the fly f1, there's a bunch of parameters. This is a real object that I create, fly f1. Okay, I still have to create that at the server side. And the thing is that when and the other thing which is important is that for every object I create, I actually need to make sure the server will know their object identifier. So that's why in the code, you will see that I have 4 parameters from the beginning. This 4 parameter is generic, that every object need to have this 4 parameter. The first parameter is URL. The second parameter is VSID. The third parameter is a class name. The fourth parameter is something which is very critical, is object identifier. So essentially what we are saying is that when we go back here, when I actually make a call, this call and the remote will be routed to the server. And the server need to do a binding. Basically, the server need to take a look at the RPC attribute and try to find out what is the class ID and what is the object ID. And using this tool, I will be able to know that this particular call is actually for this particular object, fly f1. And once that was binded, then they will call this function with whatever argument parameter that's also being delivered through this call to f1.getDistance. So essentially, let me explain the server side first. So the server receive a request. It will check. I mean, of course, the request itself has correct URL, port number. That's why if you don't have that, I won't be able to even receive it. So once I get it, it's really the problem of class ID and object ID. So with class ID and object ID, I should be able to identify the reference to the real object F1, and then I'm going to invoke the function that associate with that object. And with there might be argument, I need to include it, and when I call this function. And then the result return from get distance will be passed back to the server, and the server will reply that result to whoever called this function. Okay, so this is on the server side about what's the action will happen. The non-trivial one, in my perspective, is how do you identify which real object based on this JSON RPC protocol? How do you actually be able to identify that F1 is the object that you need to make the call? Okay, I will stop here, hold it for 1 second. Any question?
Yeah, Professor.
Yes.
So at what point is the real F1, the real flight object made? Is it made after the left-hand side program passes through JSON RPC?
Oh, when is the fly F1 created, constructed? Is that your question?
Yes.
It was created in advance. So think about this way. If I'm going to have an object called flight, right? That this object must already exist somewhere. I mean, in this picture, when you want to call this function, right? In homework 2, you must have somewhere in your code before you can call that F1, call that F1.getDistance, you must already create that F1. The difference between 2 and 3 is that you still need to create this in advance, but the difference is that the fly F1 creation of the object was done in a separate process in the server side.
Okay.
So, okay, so let me actually show you a piece of code that then this might help you to understand this a little bit better. Can you see my screen?
Yeah.
Okay. Just let me know if you lost the screen, you have to let me know. And otherwise I will be talking to myself.
Okay.
This should be ecs36b. HW3Part2. Okay, home server must have a main function, right? You see that when I have a main function, I already have all this created. Person, fly, they're already created, like here. Basically, when I start the server, the first thing I did is I create all this object here. Okay, so for example, I create F1 at the HW3 server. I'm looking at the simple case, okay? Just I haven't talked about this indirect, means that you go two level of indirection to access to a real object. Now I just talk about F1, which is in fact, this line, essentially you kind of copy from whatever your homework 2 equivalent, and just adding this 4 parameter to say, you know, what's your class ID and object ID. Okay. All right. So I'm actually going to show you this piece of code is a bit hack, but I'm going to show you anyway. Let's look for object ID. Let me see. Let me actually just search for 0, 0. How many 0? 1, 2, 3, 4, 5, 6, 7, 0. 3, 4, 5, 6, 7, 1. Okay, so you can see that here in the code of the server. Let's see where it is. This one is conflict of interest. Okay, this is the function that I define. Every member function I like to support remote procedural call. I actually have a function with RPC, but this is a different design. You can decide whatever you want to do. But I do have like action, argument, and this 4 parameter, like class ID, host URL, those 4. And then if you can come over here, what I did here is that I let the class ID, whether the class ID is equal to flight. I'm actually doing manual checking. I didn't use a table or anything. And then I check whether the object ID is equivalent to one of the three. If they are actually right, okay, then I just basically, I know that this ID is actually correspond to F1. And then I actually have a table pointer over here I call F1 pointer. So I just basically call F1 pointer conflict of interest, okay? And this one, because it doesn't take any parameter, so that's okay. You can call it this way, F1 conflict of interest. But I want to see operator equal equal, which is more, by the way, any question before I move to operator equal equal?
Where did you create the F1 pointer?
It's also a hack. Let me actually show you where do I do this, okay? F1 PTR. Okay, you see here I have F1 pointer, F2 pointer, F3 pointer, right? Okay, I just defined 3 as a global variable, but I actually bind it here. Inside, after I create, I just have F1 PTR is the pointer of F1. F2 pointer is F2, F3. I just actually make a 3 global pointer because I'm actually have a limited number of objects. I don't have to worry about using a table to represent. So I just do it this way.
Okay.
Does that make sense?
Yeah, it does.
It's a hack, but that's how I can do that. Okay, so let's actually look at operator equal equal. Okay.
Professor?
Yeah. Yes, go ahead.
Oh, sorry to interrupt, but I also have a question as well.
Go ahead.
So for shadowflight.cpp, I looked at the file and there's, I noticed we did shadowflight, calling shadowflight, and I'm wondering why it's not shadowflight calling flight, because I thought flight is the base class.
I will get to that a bit later. That's an inheritance issue. I will, when I talk about the client side, now I'm talking about the server side. When I talk about the client side, we'll look at the shadowfly. Will that be okay?
Yes, thank you.
Hold on for a moment, okay? So here is how I define operator equal equal. And operator equal equal, you still have similar those, but because the parameter, you see that I have the parameter I represent as the a person's class ID, a person's host URL, a person's object ID, and owner ID as well. Okay, so I actually also have those parameter is also doing this kind of checking. But I'm checking not just for the class ID, but I also need to check for, so this part is just like the, when I talk about conflict of interest. But here is the part I'm actually going to, wait a minute, where's my A person? Where I do the A person? It should be here. Oh, here. I actually check the A person. Whether if this is a 005, if this is 006, then basically I do the P1 pointer is equal. So this is operator overloading. Okay, this is only good if you have a small amount of object that you can do this. Okay, so then you can actually put this in. So just compare their object ID, and then we can actually call the function, and then return the result. The result will be returned using this type of logic. I actually take the result, construct a JSON, and then send this result JSON. So the result is actually, I believe somewhere is, hold on one second. Result, where's the result? Yeah, result is a JSON value. Result is a JSON value, and I basically, after I do the computation, yes, I actually take the string JSON, which is I have been constructed before. You can see here I'm using string JSON. And then I use this reader parse program to put that in. to the result. And this piece of code helped me to convert that back to the JSON format, and then I can return back to the client. Is this kind of have any question before I move on to the client side? Does this kind of give you some idea about the server side?
Yeah, it does.
Okay, now let's move to the client side. I know that there is still some detail. I'll be happy to address that when we come back. So let's actually go to the client side, okay? So the client side is that, well, now you cannot directly call flight. If you call flight, you will not get what you want. So essentially what we do is just we create another class called shadow fly. So what shadow fly really is, I call it a shadow fly is just a forwarding wrapper. It basically is not a real object. It's just know where the real object might be. And therefore, when you call me, I will forward it over there, okay? So that's the idea. So in other words, the function shadow fly, it has the same interface as the fly, because a fly is the parent object. So whatever function like a get distance or operator equal, they should have it. They have the interface, but they are actually make it into a virtual function such that their implementation of get distance is actually different. So instead of executing the real get distance, they're actually make a remote procedure call to actually call the one on the server side. So let me actually just use Shadowfly as an example. Okay. So maybe since I'm here, I'm going to use Shadowfly. Okay, so Shadowfly, they also have constructor, but you can see that their constructor is just 4 parameter. It's just 4 parameter, host URL, BSID, class ID, and object ID, right? Constructor is not interesting, but let's just look at the get distance, okay? Just look at see what get distance is doing. So get distance is doing is that, okay, I know where the object really is because the host URL is the URL that you actually, when you create it, when you construct the object, you should have that. So essentially, you're going to use what we call HTTP client. This part is the framework under JSON RPC. So JSON RPC is based on HTTP protocol. So that's why when you link the program together, you will see -L HTTPD or -L curl. Curl stands for CURL. So those library give you a very nice HTTP protocol framework set up. Okay, so you have to first, at that moment, you create a client. So you don't create a client until you actually call the function. After that, you just done. Just like you can think about this as your program is doing a HTTP request, is visiting a web. Okay. So then you're going to do, you create based on the HTTP client, you're going to create what we call HW3 client. So HW3 client is actually from the JSON RPC. Is from the JSON RPC based on the protocol. So let's actually take a look where HW3 client was defined. So this is defined in HW3 client.h. Okay, so this program is generated by JSON RPC. And you can see that it's based on the JSON, it creates automatically a class called class HW3 client. And it's basically inherit from JSON RPC : client, which is a general client structure. But what they have is that for every function you specify in the whatever the JSON file that you go through the JSON RPC stuff, it will create the entry and it create function. For example, this is all automatically create. like this one is JSON get distance, right? This is get distance, great. And then it actually, you just put in the parameter. You have to check what parameter you need to put in. And then it basically just create a JSON. Okay, now you see we're doing JSON again, and just put in whatever you fit into the system into this nice JSON. Okay, after they put in this nice JSON, this is a JSON RPC. It will just call, it will just invoke this function called this call method get distance, and with that JSON P, boom, your result is done. And after you execute this particular piece of code I highlighted, this call is routed to the server. And the result, remember I showed you earlier that I've actually construct a result JSON, and that JSON will be passed back to this result. And therefore, then I'm going to return the result to whoever called it. Okay, so essentially, this is the class HW3 client is produced based on what you specify in that I think I call it ecs36b underscore hw3.json, and that is according to that. Okay, and so now I come back here. You see my client code is very, very simple. So I basically first I create a client. I still have to instantiate based on the HW3 client. I call this, I create an object, which is called, based on the class HW3 client called my client. And also I have my, I create, because I need to have the getting back the result. Here I should really call result. I call it my V, but maybe I should call it result. But what I did here, you can see I just call my client.get distance. I said, I mean, this is like a pigeonhole. If you look at this one by one, the first one is the action. The action is get distance. The second one is the argument. And I basically, for get distance, there is no argument. So that's why I just say this is a fly JSON string, anything. And then this is, you can see now then it's a class ID. I would just say class ID, host ID, object ID, owner ID. After I call it, and then I just basically return if there is an error message, sorry. And then I would just, okay. This part you don't worry about that right now, okay? This part is called web reporting. This part, everything web reporting, you don't need to worry about that right now. This part is all web reporting. But then the final one is that you return the distance to the caller. Okay, so the way you do it is my V double quote distance, because you extract that attribute from JSON, and then you want to interpret that as a double. So you say as double, and then you return to the function. Okay, so that's what Shadowfly is implement, is basically provide a forwarding wrapper for the call that follow the JSON RPC protocol to actually send it to the remote. Did I go through that too fast, or everything is okay, or any question?
So we also have to check if two-person objects are identical, right? So
that's operator equal, right?
Yeah.
You're asking operator equal?
Yeah. So would we have to create a shadow person class too?
Yes, I have. I do. You do need to have a shadow person. Let me actually show you operator equal. No, operator equal is two-person.
Yeah.
So you have to do shadow person dot. Let's take a look at it's the same thing. Let's look at operator equal, right? Operator equal, the interface you have with shadow object should be identical to the non-shadow one, right? So this is the prototype is, I said shadow person color operator equal. This take one parameter exactly like what you have for for the real object. But let's take a look at this as an example. The example is still number one I create, right? I create this object, HTTP client, and create HW3 client. This part is identical, right? This part is really identical. And now I'm just calling this my client.operator equal, and this is also defined in HW3 client.h. Okay, so this one don't modify. operator operator equal. See, this is operator equal, and it has a lots of parameter, and it just help you automatically put this into the pigeonhole. Each of this you define in the JSON file, and when you call it, you just basically put it in like this. A person class ID, a person URL ID for the parameter, and then you put operator equal. I mean, by the way, the order of the parameter, it's actually defined by the JSON RPC stub program. It's not defined by me, because I actually, if you notice that when I arrange my ECF30, let's actually take a look at this. Sorry. Owner. Okay. I call it ECF36b homework3.json. Is that right? Yeah. Okay. So you see that if you look at my spec for operator equal, I define it like this way. Actually, the first one is action. The second one is owner ID. I define in this order. But when the JSON RPC stub program, they generate the code, they actually rearrange this parameter alphabetically. So the first argument is a person.class ID. And the second one is a person host URL. So they rearrange that. So when you write your client program, like in the shadow person.cpp, you have to read what they arrange the order in HW3 client.h. That code you cannot modify, but you should look at it to see how they arrange the order, because you're going to provide exactly the same order to make sure the program works correctly. So you can see that everything is really the same, because I'm just a wrapper, right? Put in the information without worry about anything else. Yeah. Does that make sense, Akshay?
Yeah, it does.
Some sense. Yeah. Okay.
So it looks like you've added more information to the .json file that's in the upper half than what was given in the homework file.
Right. I mean, that is, I give an example about what you can do, but you can actually add it to that. In fact, some of the students, when they implement, they didn't even differentiate the name of the function. They just had one function. They encode the name as one of the attribute. So instead of like me, I have a multiple, they only have a one, but they will be able to tell by the name. But then they have to handle the return value as well.
Okay.
But this is the way I define it. It make it a bit more complicated. But the number of functions it should be the same. Is get distance is one, conflict of interest, and operator equal. I think there is a fourth one, which is get VSID. I have 4 of them. Oh, 5. Oh, the fifth is a web report. Don't worry about web report right now. Okay. So I think Scott Joseph, you asked earlier about the question about shadow slide. What was that? Did I address your issue, or maybe I haven't covered that? Can you repeat what you said earlier?
Oh, it was just about a constructor. Akshay helped me. Akshay told me the reason why. So
Okay.
I
Okay.
cleared up. Thank you.
Okay, thank you, Akshay. Okay.
Yeah.
Any question for this part of explanation before I move on to other issue? Okay. Yeah, go ahead, Joseph.
Oh, I'm wondering why h3 client.h is not included in the tar file. But
Because it will be automatically generated. It will be automatically generated. So you we don't need to. I mean, oh, by the way, it should have a make file. Did I have a make file in the included?
Yes.
Okay, so you see I have a make, this is a make file, and inside I have a make file, say HW3 client.h, which is depending on ecs36b HW3 JSON, and I just call this function, right? JSON RPC stub, and put this is a JSON, and then the other is just the name for the HW3 client and HW3 server. And by the way, this line will actually generate both HW3 client and HW3 server. Okay, have you noticed that these two are the same? This line and this line, they're the same. I mean, basically, they would either of them will generate both HW3 client.h and HW3 server.h. Both of them will do that. And the reason I do that is like a makefile engineer to make sure that just in case that you only want to compile the server side, not the client side, that either way it will work. Yeah. So that's why HW3 client.h is and the server.h has not been included. And you shouldn't change the code. You shouldn't change the HW3 client.h, both .h file. If you want to change something, you should change the ecs36b underscore HW3.json, because that will alter the content for those two .h file. And you can see my my program. I actually have HW3 client, and then which actually has HW3 client.cpp also depend on HW3 client.h. Okay, so you should this piece of code is you have to develop, and but this piece of code don't change it. Yeah.
Okay, thank you.
You're welcome.
Professor, I just typed make, and as expected, like the .h file is generated, but I'm kind of confused, like where is the flight .cpp, because I thought shadow underscore flight is like inheritance from flight, or we just directly inheritance from transaction.
No, shadow flight should be inherited from flight. So let me show you my shadow flight.h. My shadow flight.h is very simple. You see that is these two are just for the protection of the code. By the way, I forgot whether I mentioned I should have mentioned in one of the lecture that this three statement, this three line, this two and this line is try to protect this include file get included more than once. Okay, so that take care of that. And now you can see that I actually have this line. I include transaction.h, but the reference code I send you, I think the class flight is you don't have a flight.h or flight.cpp, but you have a transaction.h and transaction.cpp, which has the definition of the flight. And that's why I will show you my transaction.h code, but you can see that the class shadow flight column is public flight. And it basically is everything the same because inherit, but it has a virtual function. There's two virtual functions for get distance and conflict of interest, because I want to have a virtual version over there. Okay. Okay. Now I'm going to show you what my transaction.cpp transaction.h looks like. So this part is similar to what you have, except I have a core. Okay, so I have a class transaction of a class core, and the rest should be the similar to your homework too. Okay, and then I have airline. You can neglect airline, but then I have class flight, which is a public transaction, and inside the fly, I have a bunch of new thing which shows the specific to the flight. So that's the structure that should be include the code I send it to you. Is that right? This piece of code should be included and send it to you already, right?
It
Yes.
is.
Okay. All right. So I want to show you their relationship. Their relationship looks like this. The relationship actually looks like this. This is the oh, sorry, I moved these things here. So this is the inheritance hierarchy. So the core is basically has this 4 argument, because this is actually every single shadow object or distributed object, I need to have this 4 parameters. So I associate this 4 with core. So that's why person, you can have a shadow person, and fly, you can have a shadow fly, because they both share the common ancestor core. Okay, right. And then basically the inside the fly, I have a virtual double get distance, and the server side is having the fly, but then the shadow is actually getting the shadow fly version of get distance. And essentially inside, I show you the code, essentially the get distance is going to call this call method, right? I showed you earlier in the shadow underscore fly.cpp. It's actually call that method, which it will transfer to the server using RPC protocol, and then it will actually handle through that way. So that is how the inheritance hierarchy was utilized with virtual function to support the relationship between the real object and the shadow object. So essentially, what we're saying here is, this is an important thing about this design, is that if you write a program, interact with a bunch of objects, you really don't need to know whether they're a real object or shadow object. You really don't need to know, because they're all considered, because a shadow fly object can be also casting as a fly object pointer, right? So essentially, when you are presenting an object, I said that this object is a flight, you actually don't know whether it's a shadow fly or is a fly, because that information through casting is gone. So all you care, your application program only care that this is a fly object. It has that interface that I can talk to. And the thing is that, however, the virtual function will take care of the difference. That's why I want you to use this example to really understand what virtual function is doing. Because if this object was originally created as a shadow object, then this function will get called. But if this object is a real object, it's created as a fly, then this function will get called. Okay, so that's why this hierarchy is actually help us to implement this kind of transparency or whatever, the wrapper perspective, that when you write a program, a piece of code to access to the fly object, you really don't need to know where they are, whether they're shadow or real, which location. It will actually automatically figure out by the virtual function mechanism. Does that make sense? Or what I say is totally hard to catch up, follow?
Yeah, I'm like I'm like looking at code. I'm trying to like catch up like the shadow, like what it like really means. Because it's kind of like, because I just watched a video about homework 3. You upload it to YouTube, and it's kind of conceptual, I would say.
Mm-hmm.
Yeah.
So it's conceptual. That's not good, because conceptual, usually programming, we have to see the code, right, to actually see that. I hope that this lecture, what I'm just sharing here, will give you a better idea, because I show you segment of code. I mean, it's line by line how the control is transferred. Let me actually go back here, okay? Let me do this. I was showing this picture. Okay, so now I'm annotated with the file that's actually involved. Okay, so I'm going to say this first piece of code is the first piece of code. Where do I do this? The first piece of code is what I call HW3 client.cpp. But I want to change this to a font which represent. I want to represent a font which is like Menlo. Is there a font called Menlo? Yes, Menlo. Okay, and then I'm going to put a color green. Anytime I use green, that means it's piece of code. Okay, so the file. I mean, this piece of code should be from HW3 client. But the thing is that to create that shadow fly, then you're actually going to also looking at the client side is shadow fly.cpp. So over here, the client side is really this two piece of code. That's actually we review, right? And over here on the server side, the one that's actually take the JSON out of the JSON RPC protocol is HW3 server.cpp. Okay, it's HW3 server.cpp. It's handled basically, I'm actually going to put it here because it's really involved a lot of hooking. I mean, in fact, the most complicated code is probably HW3 server.cpp. It's not that complicated, but it is the most of action. And this part, when you really call to the fly object, now this is fly. Is actually transaction.cpp. Because I actually, this is a bad example. I didn't define another one called fly.cpp. I just merged into transaction.cpp historically because Professor Wu is lazy to do another one. Okay, just get it to work. So what you need to know is that this picture without this 4 green box, it gives you a concept about what's going on. But it's important for you to look into the code. At least this has been recorded. You can see on the video what code segment I have, and essentially understand how HW3 client.cpp is going to call a function in shadowfly.cpp, which will receive by HW3 server.cpp, and then it will be calling another function, which is getDistance, defined in transaction.cpp. And then it will return back to server and then return back to shadow. And then finally, the result will return back to HW3 client.cpp. So if you go through the code by line of the code to go through that, then this will help you really understand what's going on, not just conceptually, but you see that how the program is really working together. Okay.
Thanks, Professor.
Mm-hmm. Yui, please. I cannot hear you.
Oh, I just say thanks. I'm like this is like much helpful. than conceptual stuff.
Sure,
Yeah.
sure. I completely agree with you. Yeah, that's why I want to do this conversation with you guys. I know without this is hard for you to guess to grasp the homework. Okay. All right. I'm going to let me stop here and share the screen, and then I will answer any question. Okay. Let me stop recording first.